in some cases, language was a major problem. We were dealing with 3 Montana schools in 3 different communities, for starters, and then we were dealing with teachers in 3 different continents. With the students in Mali, they're in 7th, 8th, and 9th grade, their English was minimal, and the teacher's English was minimal, but it was possible to communicate in English. In Mongolia, the teachers were speaking and the students in their own Mongolian language, and so that had to be interpreted.
The biggest challenge is time and how to fit it in your curriculum. I, like other science teachers all over the country, have a set curriculum I need to cover. I have a set of standards. I have a high stakes test that comes in the end of April that I need to cover material. So the question becomes how to fit it in. What does my curriculum say? What do my science standards say? And how can I take a project like this, and what key standards and what key terms and what key concepts can I build in this project so that I'm not losing any time? The effort that we spend on this will be utilized. It'll be utilized in terms of, I'm just replacing what I did with something that was better. Whereas I used to talk about soil types and soil things in a separate curriculum unit in a chapter, this is where I covered it. This is where I could weave it in. So that was a huge area. Another area that helped me is we have an applied science type class that we could take and doing a lot of work in that class. So a lot of time could be spent there, and then we could come back to the main group, the main curriculum, and share that. At first I was worried about that because what I just said right there encompasses a year, and yet we're not doing it all the time. So we might do it on Tuesday because that's convenient, or we might then again the next Wednesday, and then again the next Friday. And I thought, boy, is this going to be so disjointed. That turned out not to be a problem. In fact, it turned out to be a strength because it meant that throughout the year you're constantly bringing and weaving this in, and you really are. When I'm talking about forces in motion and talking about controls, I can point to our plant growth center and show our plants that are growing in our forest soils and use that as an example. So I could all the time keep coming back and reinforcing. So, you can bet that those kids taking a high stakes exam that have to work with data tables and controls and things like that that are on our state exam, they're not going to have a problem with that. They lived and breathed that. So I think the challenge is, how do you fit it in your curriculum? The short answer is look for ways that concepts you're already doing that you can fit in and make work with it. Something that's not a challenge in this is the money. That's not a challenge because you could just pick issues and problems that you have equipment or that you have resources to answer. So that's not a challenge.
I think a science teacher may want to, first of all, think about their own science the science issue in a broader way and just begin to move locally. Bringing in an international component sometimes requires a scientist, a local scientist, who already has that other connection.
I think for teachers that are going to get involved in science research, go in baby steps. You're seeing a great big project here that multiple partners, university partners, it's huge. My early work in this endeavor was we got some tomato seeds that were up to the moon and brought back and distributed to science teachers way back in the early ages. And my thing here is, what do you want to do with it, students? What shall we do? What shall we look at? So that was a baby step. It was just here in the classroom. It was a quick kind of deal, could be, a science fair kind of deal, but it was the beginning point. The next step after you do it in your classroom, start to involve partners. Students really get excited when there's the school down the road, or the 2nd grade class and you're the 8th grade class, or you're the 8th grade class and this is the senior advanced biology class. When you involve partners, it all of a sudden takes on a new dimension because you have communication. And when a big part of science is communicating. And then another step is, out of the school and then even to the international realm. My students were fascinated looking at pictures and seeing students from Mali, reading reports from Mongolia. Just fascinated to look at Mongolia on a map and think that that report, that email, is from that particular country. So, you know, start small, but go for the gold at some point.
Another suggestion for those who would like to start a project like this is to go to the internet to our website, which is www.montana.edu//Mali. There's a section for secondary ed, and there's also a lot of scientists that are talked about locally, and for instance, we just had a new school become involved in Virginia just because they went onto the web, they found my address, they used the materials from a village school in Mali via our website, and they created quite a very interesting unit and now have a connection to the village school in Sanambale just by starting out with the web. The most important thing that I saw happening in the project was that there was a cadre of very enthusiastic science teachers.
I think whenever we empower learners, we say to learners, this is yours. I'm here to help you. I'm here to be the facilitator. I'm here to be the guide. I'm here to show you resources. But this is your project. I think that's really powerful. And this question was students. We didn't say, students, here's 5 questions. You pick the one you like. We didn't say that. We said, let's go out and look for problems. When we find a problem, let's come up with a research question. And students come up with a question. The teacher's saying, well, yeah, but what about this? And then pretty soon students start saying, yeah, but what about this? And so when it's finally done, if it's done right, it's their question. And I think that's an incredibly powerful thing to give to students to make some things happen.
The students were engaged, and the project was designed to engage students, and it indeed did very, very well.
Because we're working with partners and we're exchanging, in many cases, information, write-ups and data tables are absolutely essential, you know, as a science classroom teacher before getting involved in this kind of material, to try to make students understand why well-written documents are important, why well-written standard operating procedures are important, and why well-labeled data charts are important. They had a hard time with that. But when they start exchanging their own information, my students will say, hey, how come this column isn't labeled? Or what unit is this? We don't know what this number means. We don't have any label for it. So all of a sudden learning becomes very, very practical and very lasting because it's very relevant.
The fundamental new idea within this project was connections. It was the connections with other scientists, with other science teachers, and with local scientists, and with other countries.
You have the potential when you're doing this kind of research and empowering kids that you can have kids that may go into science fields because this is kind of cool. And I talked to a scientist from Montana State University, and I was up there in the potato lab, and I was looking through some things in the potato lab, and wow, I really like this. And so you can have some real significant decisions being made in middle school by students that encourage what they do the rest of their life because the teacher takes time to, you know, do a science research project with the students.
One of the major ways that this project will have an impact is in the way that the science teachers teach science. I think they're going to understand that it's important to reach out into the community and actually do science and solve real problems. Another thing that the scientists or the science teachers have learned is that they can call on local scientists who are more than happy to help them. And I think the science teachers have seen how helpful that is to bring the scientists into the classroom.
I absolutely saw students who were involved in the projects grades go up, absolutely. They understood the process of science, and if you're assessing by the process of science, they really have that down. They use it again and again and again in answering questions and building tables and collecting data. They get so they do it. So that's a very powerful idea.